Hello friends, welcome back to CSharp.net online training video series. Today we are going to discuss method overloading in C Sharp. In our previous video, we discussed polymorphism and we discussed that one of the way to achieve static polymorphism or compile time polymorphism is by using the concept called method overloading. So today we are going to give a brief today I'm going to discuss method overloading in detail. So as part of this video, what we are going to discuss? We are going to discuss the following 8 pointers in detail with example. First, we will discuss what is method overloading in C Sharp. Then we will discuss when should we overload methods. Then we will discuss if we are doing method overloading, then what are the advantages we are getting, right? Then we will discuss when is a method as considered as overloaded method. Then we will discuss one important concept, that is inheritance based method overloading, right? Then we will discuss some real-time scenario where we can use method overloading. We will see what is constructor overloading with one example. Then I will show you one real-time example, that is logging by using the method overloading concept, right? So all these things we are going to discuss in today's video. So the first note point what I mentioned here, the point that you need to keep in mind is function overloading and method overloading terms are interchangeably used, right? So if I am saying method overloading and if I am saying function overloading, means both are going to be same, and method overloading or function overloading is one of the ways to implement compile time polymorphism, right? It is one of the way, means there are other ways also available. What are the other ways? Operator overloading, method hiding. There are other two ways that are also available in C# language to implement this compile time polymorphism. Today we are going to discuss method overloading. In the next video, we are going to discuss operator overloading, and then we will discuss method hiding, right? All the concept what we discussed in our previous video, we are going to cover in this video and in our next video. So let us discuss what is method overloading or function overloading, right? See, method overloading means what? It is an approach to defining multiple method under the class with a single name. So what it means? It means we can define more than one method with the same name in a class. In a single class, we can define one method with multiple times. But the point that you need to remember is the parameter of all those methods should be different, right? The parameter should be different, means the parameter order should be different, the number of parameter should be different, the type of the parameter should be different. So if we are defining multiple methods with the same name but with a different signature in a class or in the parent child classes, when I'm saying parent child classes, so if you remember, we have mentioned one concept, inheritance based method overloading. So that means inheritance based method overloading means we can define the same method with a different parameter in the parent class as well as in the child class, and if you do, that is called inheritance based method overloading. And whenever we are doing this, so we are saying it is method overloading. That means C#.NET not only allows method overloading in the same class, but also it allows method to be overloaded in the parent and the child classes. So what we can do is we can create a method in the parent class, and we can also create a method in the child class with the same name but with different parameters. And if we do so, then it is called inheritance based method overloading, right? In simple word, we can say that method overloading allows a class to have multiple methods with the same name but with a different signature. Same name but with a different signature, right? That is the point that you need to understand. The functions can be overloaded based on the number. So one method might be taking one parameter, another method might be taking two parameter, one method might be taking three parameter, like this type. One method taking integer, another method might be taking float, one method taking integer float, another method taking string, right? So type and order of a parameter. One method taking integer float, another method might be taking float and integer, right? So we can overload the method based on the number of a parameter, based on the type of the parameter, and based on the order of the parameter. For better understanding, please look at this image. So you can see in this, suppose this is one class. Inside this class, I'm declaring these 5 methods. And if you look at all these 5 methods, the name is going to be same. All the method having the same name, that is method, right? But if you look at the parameter, then you will see the parameter are going to be different, right? Now let's compare these first two methods. In this method, the parameter we do not have any parameter, but in this case, this method is taking one integer parameter, right? So if I compare these two methods, then these two methods are different in the term of a number of a parameter. This method taking zero parameter and this method taking one parameter. Now, if I compare these two methods, right, method 2 and method 3, then you will see that the number of a parameter is going to be same. This method taking one parameter and this method also taking one parameter, but the type of the parameter is going to be different. This method taking integer parameter and this method taking string parameter. Now, if I compare these two methods of third and fourth, then you will see that this method are different based on the number of parameters. It is taking one parameter and it is taking two parameters, right? Now, if I compare the last two methods, then you will see that the number of a parameter is going to be same, two parameters. The type of the parameter is going to be same. That is, this method taking one integer, one string. It is also taking one integer and one string. But the order of the parameter is going to be different. So in this case, first integer, then string, and in this case, first string, then integer. That means the order of the parameter is going to be different. So the point that you need to remember is overloaded method means the method name is going to be same, but the number, type, and order of a parameter is going to be different. That is the point that you need to keep in mind, right? So to understand this thing, let me copy this code and put it in my Visual Studio. So you can see, so here I'm declaring one method, two method, three method, fourth method, and fifth method. All the method are having the same name, right? So you can see all the method are having the same name. This is no parameter, one integer, one string, integer, string, string, and integer, right? All the method are having the same name, but the parameter are going to be different. This is nothing but we are overloading this method, right? And the overloading and by using a method overloading, what we are achieving? We are achieving compile time polymorphism. Why compile time polymorphism? Because at the time of a compilation only, we resolve which method is going to be executed at runtime, right? So in this case, this is the program class, this is the instance of the program class, and this is the reference variable of the program class, right? So this reference variable identify that this method, which doesn't take any parameter, is going to be executed at runtime, right? And as we identify this at the time of program compilation, so we can say that this is compile time polymorphism. And you can take any method. So in this case, the compiler binding this method call with the method which is taking one string parameter. Where this method is defined, this method is defined here. So you can see, as soon as I select this method is highlighted because compiler know that this method is going to be executed at runtime. Now if I am checking this method, right? As soon as I select this method, you will see that this method is highlighted because compiler know this is the method definition which is going to be executed at runtime by the CLR. As we resolve the function call and its function execution at compilation time only, we call this as compile time polymorphism. Now, if you run the application, then you will see that each method is executed once, and what statement we have written as part of the method body, that is nothing but one print statement. And each print statement, you can see this is first method, second method, third method, fourth method, and fifth method is printed on the console. This is nothing but method overloading, and using method overloading, what we achieve compile time polymorphism, or you can say static polymorphism. And one of the point that we need to remember while we are working with method overloading, the method overloading only consider the method name and the method name and the method, not the number of parameters the method is taking, but it never consider the return type of the method as its parameter. I mean, the return type is never considered as part of a overloading method. For example, so you might be think that this is one method and this is the both method name is same, but number of parameter is same. But in this case, what I'm trying to do, I'm making this method return type as string. And what I'm trying to do, I'm making some string parameter returning, right? Some string value I'm returning from this method. But as soon as I do this, so you can see I'm getting some compilation error. What is saying, the program already defines a member called method with the same parameter type. What it means, now whenever you are defining the method, right, method overloading concept is there, then the method overloading is never considered return type as part of the method overloading. Whether you write void, you write string, that is never coming to the picture, right? What he is going to check? He is only going to check the method name and the type of the parameter, the number of the parameter and the order of the parameter this method is taking. And in this case, we have defined one method without parameter, and in this case, we have also defined one method without parameter, right? So in this case, that's why it is saying this program class already defined a method called a method with the same parameter. Now, if you come to this place, right, and if you try to invoke the method, let's assume that compiler allow this. Let's assume that compiler allow this. Then at the wrong time, sorry, at compiler allows this. But whenever you try to create an object and whenever you try to invoke the method, right, what will happen? Which overloaded version is going to execute? Can you identify? No, I cannot identify. Why? Because there are two methods which is not taking any parameter. So the compiler is only getting confused which version to be executed, and hence he will provide you the ambiguity error, right? So if you took, then you will see that the call is ambiguous between the following method or properties, method and method. That is the reason why the return type is never considered as part of the method overloading. See, let us understand why return type is not considered as part of the method overloading. Please have a look at the following image. Here I have written two methods, what I have shown in the editor, right? Same method name but with a different return type. One method taking void parameter and another method taking string parameter. As soon as we type this method 2, we will get this error. The type program already defines a member called method with the same name and same parameter type. So at the time of defining the method only, compiler gave us an error, right? So while we are defining this method, we will only get the error, right? Now still you may have wondered, sir, return type are different, then why it is going to be invalid? To understand this, let us try to invoke the method. Right? Then what we did, we create an object and then we try to invoke the method, and we see what problem we face. We face the ambiguity issue that we have already seen in the Visual Studio C. We are getting the ambiguity issue, right? Still you have doubt. The return types are different. See, the return types comes into picture at the end of the method execution only. Here, the compiler not getting confusion, right? Here, the confusion is not at the end of the method execution, but the confusion is about where to start and which method to invoke, right? Here, the compiler not getting confused what the method is going to return, right? The compiler getting confused where to start and which method to be execute, right? That is the point that you need to remember. The compiler doesn't have any clarity or any idea to start the method, where to start the method execution. And talking about the end of the method execution doesn't make any sense. We are unable to start the method execution and you are talking about the end of the method execution. This doesn't make any sense. So this is the reason why return type is never considered while defining method overloading, right? So they are never considered as part of method overloading. When should we overload method, right? We have understood what is method overloading. We have understood how to implement method overloading, right? That is fine. But the important question that should come to our mind is when we need to implement method overloading or when we need to go for method overloading in our application development, right? See, the concept of a method overloading falls under the polymorphism OOPS principle, right? Apart from polymorphism, there are other OOPS principles also available like encapsulation, abstraction, and inheritance. And all these three OOPS principles we have already discussed in our previous videos, right? Today and in our next 2 or 3 upcoming videos, we are keep focusing on the polymorphism OOPS principle. Then the first question is, what is polymorphism? Polymorphism is a mechanism of changing the behavior based on the input. What it means? It means when the input changes, automatically the output or the behavior going to be changed. The best example of polymorphism is ourselves. For example, when we hear something or when we hear something which is good for us, we feel happy. And when we hear something which is not good for us, then we feel sad. Suppose you ask your father to purchase a bike, and if your father purchases a bike for you, then you will feel happy. And if your father says, I'm not going to purchase a bike for you, then you will feel sad. So you are the same person. When you receive something good, something interesting, right? Then you feel happy. And when you receive something which is not good for you, then you will chat. This is nothing but polymorphism, behaving in different ways based on the input received. That is, whenever the input changes, the output is also automatically changes. And in our previous video, we have already taken many examples. Society of women in the society, liquid water. We have taken the example of a security guard, right? So many examples we have discussed in our previous video. If you have not watched that video, please watch so that you will get a better idea related to polymorphism, right? Here the input changes means doesn't think that the value changes. Input changes means when we change the number, type, and order of the input values. Don't think that if I pass 10, I will get a value, right? If I pass 20, I will get a different value. This is not the case. For this, if else condition is sufficient, right? Overloading is not required. When you expect the output to be changed based on the number, type, and order of inputs, then only you need to go for method overloading, right? For example, let me explain you this concept with an example. See, what I'm doing here, I'm declaring one art method. So my requirement is to declare one method or to provide some functionality where if I pass two integer number, then he is going to add the two integer number and show the result. If I'm going to pass two floating number, then I need to add the two floating number and I need to show the result. But if I'm going to pass two string value, string we cannot add. So what we can do, we can concatenate the string, and whatever I am passing, I need to show by spacing a separate by concatenating them by using the space, right? So in that case, what you need to do, you need to define three methods with the same name but with the different type of a parameter, right? Here I'm taking two integer parameter, here I'm taking two floating parameter, and here I'm taking two string parameter. The method name is going to be same, but the type of the parameter is going to be different, right? Now if you are passing two integer means this method is going to be invoked. If you are passing two string means this method which is taking two string parameter is going to be invoked. So this is nothing but your method overloading based on the requirement, right? Based on the requirement, when you pass different type of values, you will get a different output. That means if you pass different type of values, a different function is actually going to be invoked. If you are passing integer, then the method which is taking two integer parameter is going to be executed. If you are passing two floating point number, then the method which is taking two floating parameter is going to be executed. So this is how you can implement a method overloading, or when you should go over method overloading. Then that is fine. Then what is the advantages? So in this case, if you practically see, these are nothing but different method only. These are nothing but different method only. Only the common thing is that the name of the method is going to be same. In this case, if I put add 2, and in this case, if I put add 3, and if I write like this, then that is also fine. That is also fine because these are actually different method. Then what is the advantages of giving the method name as same? That is what we need to understand. If I'm providing the same method name, right, then what is the advantages that what I'm going to get? See, suppose you are the user of the program class, and when you create an instance of the program class, and when you type the dot, then you will see that, see, you are the user of this program class. So what you are trying to do, you are just trying to use the object, right? So when you type the obj dot, right, then you will not see three add method. You will not see three add method. You will see one add method plus two overloaded. That means one add method which is going to be overloaded two times, right? Now if you write like this, see add dot, suppose I'm writing add, and you can see this is one add method which is taking float and two float parameter, and once I type down array, you will see second overloaded method which is taking integer, and third one which is taking string and string. So the user of our application feels that there is only one add method which is going to take different types of parameters. He has no idea whether I have implemented three methods or one method. He is the user feeling that yes, there is only one add method which is taking different types of parameter and performing the operations, right? So this is the advantages which we will get if you are using. So the advantages of a method overloading is that if we overload the method, then the user of our application get a comfortable feeling in using the method with an impression that he or she calling one method by passing different types of values. The best example for us is the right line method, that what we used in our day-to-day programming, right? If you go to the console class, right, if you go right click and go to the definition of the console class, then you will see that there is no one right line method, right? So you can see how many right line methods are there. This is the right line method started here and it is ended here. That means there is not a single right line method. There are multiple overloaded version of the right line method, and based on the parameter or based on the input value, the appropriate right line method is going to be executed. The point that you need to remember, right? So this is the advantages of using method overloading. Then when is a method considered as an overloaded method? The answer is already we have discussed. If two methods have the same name but with different signature, then those methods are considered as overloaded method. Then what is the rule that you need to check? You need to check both the method have different parameters. Different parameters in terms of number, type and order, but there is no rule on return type, access specifier and access modifier, right? We have already discussed whether you use void or string doesn't matter, whether you use private public doesn't matter, whether you make the method as static shield virtual doesn't matter, right? But what matter is the name and the parameters. That is what you need to remember. Can we overload method in the same class? Yes, it is possible. We have already discussed in our example. You can see we have already discussed this concept. In a single class, we are overloading the methods, right? This is possible. Method can be overloaded in the same as well as in the super and subclasses, right? Super and subclasses means you can overload the method. You can declare one method in the parent class with one parameter, and you can also define the same method. Same method in the sense we can define another method with the same name but with a different parameter in the child class. That is inheritance-based overloading that we will discuss now, right? But before that, one point that you need to keep in mind that you can do method overloading in a single class, but you cannot do method hiding in the same method overriding in the same class, right? Method overriding is not possible in the same class. For method overriding, you need parent and child classes, but for method overloading, it is possible in the same class as well as it is also possible in the parent and child classes. What is method overriding or how to implement method overriding? We'll discuss when we will discuss method overriding concept, right? Now, one more important point, right? It is also you need to understand what is inheritance based method overloading. A method that is defined inside the parent class can also be overloaded under its child class. In the parent class, you define the method, and if you want, then you can provide the same method with different parameter inside the child class. And if you do so, then it is called inheritance based method overloading, right? For better clarity, let us consider this example. So what I'm trying to tell you is, so this is my class 1, and inside this class, I'm defining two methods with the same name. But if you remember, this method taking two integer parameter and this method taking two floating point parameter, right? This is my class 1. And this class 2 inherit from class 1. That means now class 2 become a child of class 1 and class 1 become the parent of class 2. That means these two methods are also available to class 2, right? And in class 2, I'm also defining two. I'm also defining two methods, but with different parameters, right? So this is nothing but inheritance-based method overloading. You can define the method in the parent class. You can also define the method in the child class with a different parameter with the same method name. And if you do so, then this is inheritance-based method overloading. Now, you can create an instance of child class and you can call the method, and the compiler will decide, yeah, this is the method I need to execute from this class, and this is the method I need to execute from this class, and this is the method I need to execute from class to C. As soon as I select this method is highlighted, because compiler will only will come to know that this method execution is going to be happen at runtime, right? This is nothing but inheritance based method overloading, right? To overload a parent class method under its child class, the child doesn't require any permission from its parent, right? So in this case, this child class doesn't require any permission from the parent class. Why? Because we are giving the method name as same, but technically technically they are going to be different method only. As they are going to be different method, so permission is not required by the child class from the parent class. But in the case of a method overriding, Permission is required. Why permission required? We'll discuss when we'll discuss method overriding in our upcoming video, right? Now, one real-time scenario where you can use method overloading. Suppose you are working on a maintenance project. So suppose you joined a company, and in that company you got one maintenance project. So maintenance project means what? Now you are going to keep supporting what? Supporting in a work in the sense that project is already developed, that project is already given to the client, and if any kind of bug or issue come, then you need to handle the issue, or any kind of enhancement work, then you need to do the enhancement, right? Suppose you are doing some kind of enhancement, and for that you need to work in for a class. The class is already designed by the developer, and you are going to work on that class, right? And the person who is working previously have created some parameter as constructor, right? And you are going to work on a class where already some parameter as constructor have been defined. Now you need to pass some additional parameter. Those additional parameter is required because you are going to do some kind of enhancement. Then you have two options. What are the options? First, you will add the required parameter with one of the already defined constructor, and the second option is you will add a new constructor as per your requirement. So whether you will add the required parameter in any of the already defined constructor, or whether you should go for a new constructor as per your requirement. In such cases, you should not add the required parameter with the already defined constructor, because this may disturb your other class dependency structure. For example, the developer who created that constructor might be creating some object somewhere else using that constructor. Now, if you are passing some parameter, means the existing code where that constructor is used will give some compilation error. That means that code is going to disturb your application, right? That is the reason why for backward compatibility, right? To make the existing code work as expected, we need to define a new constructor with our requirement, right? To understand this concept, let me copy this code, right? So let me copy this code. Suppose this is the class, right? So what I'm trying to tell you is, suppose, yeah, let me copy this one, right? Let me copy this one, right? Let me comment it this one. So what is the requirement is, so this one developer work on this, right? One developer working on this, he is creating one constructor which is taking one parameter, and another constructor is there which is taking three parameter, right? So now you have some requirement. Now you do not need one parameter, or you do not need three parameter. You need to work with the two parameters only. Then what are the option? Option is you can pass that second parameter to this constructor, right? So what you will try to do, you will do like this: integer y and integer x. But as soon as you do this, you will get this error, because this code, this constructor is already using somewhere else in your application. So you will get this error. So you cannot do like this, right? So other option is that you can remove this integer thread, so that the existing code will going to your requirement you can achieve, right? But once you do this, you will get this error, right? So you should not do this. Then what is the best solution? Create one new constructor as per your requirements. I'm creating this constructor, and this constructor taking two parameters, and this is my requirement. And once you created this, the existing constructor functionality, existing places where you use those constructor, they are not affected, right? And as per your requirement, you can create your own object and you can use the constructor. So this is nothing but your constructor overloading. So you can see this constructor taking one parameter, this constructor taking two parameter, and this constructor taking three parameters. So this constructor overloading is nothing but it is a way of implementing polymorphism in your application, right? So in this case, you can see one, I am selecting this constructor, right? This method, this constructor is selected, means the compiler know when this call is happen, this constructor body is going to be executed. And when I'm selecting this one, the compiler decide this is the method execution. At runtime, this body is going to be executed, and for this constructor is going to be executed at runtime, right? As compiler decide, as compiler came to know that which method execution is going to be happen at runtime. So this is nothing but this is static polymorphism, or you can say compile time polymorphism, right? So this is one of the real-time scenario where you can go with constructor overloading, right? Now we will see one of the real-time example of method overloading, right? Suppose you are working on a real-time project, and when we are working with any kind of real-time application, one of the mandatory things that we need to do is logging, right? Logging means suppose you are developing one application, we are developing some APIs or any kind of application. So whenever a request come or whenever a method call, right, we need to capture the request detail, right? We need to log the log information, right? We need to log the request information, execution, any kind of information, right? Either on a text file or in the database. Even if some exception also occurred, then also we need to log the exception details so that later on we came to and we need to check the log file and we need to verify where the exception occurred and why the exception occurred, and accordingly we take care about our code, right? So for this, what I'm trying to do, I'm creating a logger class, and within that logger class, I'm implementing the multiple log method as per my requirement, right? So let me copy the code and paste it here. So you can see this is my logger class, and this is my log method, and this log method taking three parameters: class name from where you call this method name from which method you call this method, and what message you want to log. And when logging, what I'm trying to do, I'm just putting the date time, at what time this message is logged into the database, either into the database or into a text file. But for understanding purpose, we are just logging this information on the console. And this is another log file, and in this case I'm in this case I'm providing a unique ID, class name, method name, and message, right? This unique ID is play a very important role in our logging, right? See, whenever we are developing one application, when the request comes. For that particular request, we might be providing 10 log information, 20 log information, right? And at the same time, we might be get 100 requests, 1,000 requests. Then how will identify for a particular request which log information is there in the log file? We cannot identify if we are not providing some kind of a unique ID mechanism, right? If we for a particular request if we use this unique ID, wherever we log the particular request data, if we put the same unique ID, then we can easily identify based on this unique ID what are the log information we have logged into the text file or into the DB based on this unique ID. And if you just want to log the message, then you can use this log version. And if you want to put the class name, method name, and the exception detail, then I'm also providing one overloaded version, right? And you can create as many overloaded version as you want as per your business requirement. For the simplicity purpose, I'm creating these four different types of log method, right? And you can define I'm creating this inside the logger class, right? Now from the main method, what I'm trying to do is I'm trying to use the four overloaded version of the log method. So what I created, I just put the class name. What is the class name? Class name is program. This method name is main method. This unique ID GUID.newID.toString. This GUID.newID.toString will give you a unique ID, right? The number of time you invoke this method, each time you will get a unique ID. The unique ID is never going to be same, right? So the logic they have implemented based on the timestamp, right? Some other mechanism, they are generating this unique ID. You will never find the same unique ID twice, right? So this is the way of implementing the unique ID. Then I'm calling the first method, log method, by passing the class name, method name, and here I'm passing the message one. I'm calling the second by passing the unique ID, class name, method name, and this time passing message two. And I'm calling the log method, which is only taking the message. Now inside this try catch, what is try catch? We will discuss in our coming videos. But this is how you need to handle exception in your application, right? I'm not going to explain this try catch right now. So what I'm trying to do inside the try block, I'm going to write the code which might cause some exception, right? So what I'm trying to do, I'm declaring two variables. One is number one and number two, and then I'm just doing a division operation and storing the result in the result variable, right? And then I'm putting this log information, right? Message 4. And if there is if there is some error occur, then that catch block is going to be executed, and whatever the class name, method name, and whatever exception occurred, that is what we are going to log on the console, right? So in this case, if you know you cannot divide a number by 0, so in this case we will get divided by 0 exception, and in that case that catch block is going to be executed and we will catch that exception, right? Now if we run the application, then we will get a better idea, right? So let me run the application. The application is running, and as soon as the application runs, then you will see the login information. See, date time, message 1, this is message 2, message 3. And for the last one, the catch block is executed. You can see what exception we are getting. We are getting exception in the program class, in the main method. What exception attempted to divide by 0, right? We are trying to divide a number by 0, right? And this exception occurred where? Now program.cs class file, line number 39. If you go to the program.cs class file, so this is your program.cs class file. You can see program.cs class file, and the line number 39 is this one, right? So here we are getting the exception. So by looking at this code, you need to identify what wrong we have done in this code, and accordingly you need to correct this. So this is how you can implement logging mechanism by using the concept called method overloading in C#, right? So that's it for today. In the next video, we are going to discuss operator overloading. In case you need the text version of this video, the link for the same is provided in the video description section. Thank you for watching this.